So hi everyone, in the last class we have seen about the barbiturate and their derivatives. Barbiturate, their mechanism of structural activity relationship, their different classes and their derivatives. Okay, now today in this class we will see about benzodiazepines. So we will see about benzodiazepines, their SAR, then different classes and their derivatives. Okay, so let's start benzodiazepines. This is very important. Sedatives and hypnotics is an example of sedatives and hypnotics, and it is also called CNS acting drugs. So these drugs ultimately acts on the CNS mainly. So let's start with benzodiazepines. Benzodiazepines. Okay. So first of all, we will see the different classes. So what are the different class? They are mainly four types. Number one is long-acting benzodiazepines. Long-acting benzodiazepines, that is BDZ. Number two is intermediate acting. Intermediate acting. Number three is short acting, and number four is short acting, and number four is ultra short acting. Number four is ultra short acting. In these four different classes, what are the different drugs? So let's see the example of different drugs. For example, long acting benzodiazepines. What are the example of long acting benzodiazepines? They are diazepam, chlordiazepam, flurazepam and clonazepam. Write down diazepam, chlordiazepam, flurazepam and clonazepam. Next, intermediate acting. Let's write this. Diazepam, chlordiazepam, flurazepam and number four is clonazepam. Okay, these are the four examples of long acting benzodiazepines. Okay, next you have to remember that this diazepam is most important. That is very important for the point of view of GPAT exam. Okay, next you have to remember that this chlordiazepam is innovative and drug design molecule. That is artificial. So you can say first innovative. So it is the first innovative drug designed molecule. So it is artificial. Okay. Next, flurazepam. This also acts as a substituent at first position. For example, in the case of diazepam, if diazepam is not available, then you can use flurazepam also. It is the substituent, or it can be used in the place of diazepam. Next is clonazepam. Okay. Next thing I'll say is that these are antipsychotic and anti-epileptics. These are antipsychotic, and anti-epileptics. These all are about long-acting benzodiazepines. Okay. Next, we will see the intermediate-acting benzodiazepines. So, what are the intermediate-acting benzodiazepines? They are nitrazepam and alprazolam. This alprazolam leads to long time sleeping. So number two is intermediate acting. Intermediate acting BDZ. Okay. So the example of intermediate acting BDZ are nitrazepam and alprazolam. nitrazepam and alprazolam. So alprazolam is little bit important. You have to remember that along with, in the case of alprazolam, along with benzodiazepines, an extra ring is present, that is 1 3 4 triazole. You have to remember that 1 3 4 triazole ring is present. Okay, next thing is that this triazole is a 5-membered ring. This is a 5-membered ring. Next thing is that this drug is also called sleeping tablet. I mentioned just 1 minute ago about that it causes long duration and heavy sleeping or deep sleep. So it is also called sleeping tablet. Next, it is very potent drug. It is very potent drug. You have to remember that. Next, you have to remember that it is given in very small quantities. It is given in very small quantity. Okay. Next, number 3, we will see that short-acting benzodiazepines. So what are the short-acting benzodiazepines? The short-acting benzodiazepines are oxazepam, short-acting BDZ, that is benzodiazepines. So example of short-acting benzodiazepines are oxazepam, lorazepam, oxazepam, lorazepam, and temazepam. Oxazepam, lorazepam, and temazepam. Next, number 4, we will see, that is ultra short acting. So what are the example of ultra short acting benzodiazepines? They are triazolam and midazolam. Very easy. Triazolam and midazolam. Okay. Most important point that in that case of triazolam, that benzodiazepines, that is BDZ, is present along with that whatever I mentioned earlier, that is 1 3 4 triazole. So that 1 3 4 triazole ring is also present here. That is how many membered? 5-membered ring. Okay. So you have to remember that. So write in red color pen, write a short note where you have to remember that 1 3 4 triazolyl benzodiazepine. 1 3 4 triazolyl benzodiazepine, direct write BDZ. Are example of which one? Alprazolam and triazolam. These are the example of 1 3 4 triazolyl benzodiazepine. Very important for the competitive exam. Write 5-star here. Okay. Now we will see the SAR, that is structural activity relationship of benzodiazepines. First of all, you have to remember that this benzodiazepine is a bicyclic system. Why bicyclic system? Because it has 2 rings. Okay. So this benzodiazepine has 2 rings. Since, see, in this benz means benzene. Ben means benzene ring. Di means 2. Aza means nitrogen. Aza means nitrogen. And epine means, F means 7-membered ring. 7-membered ring. And in means presence of nitrogen again. Okay. By this way, you have to break down all the name of different drugs and you have to remember in this way. This is the easiest way to remember all the drugs and their structure. So in this benzodiazepine, ben means benzene ring, di means 2, aza means nitrogen, F means 7-membered ring, F-ins means presence of nitrogen. Now we will see the structure of benzodiazepines. So the structure of benzodiazepine is that in this one benzene ring will be there. Along with that benzene ring, you will see presence of nitrogen. And along with that you will see 7 structure, 1 2 3 4 5 6 7. So this is the structure of benzodiazepine. In this is the benzene ring. In benzene ring, here you will see one R group present. Here in this nitrogen you will see another R group present. Here you will see one carboxyl group or carbonyl group. Here you will see another R group. In this nitrogen it will be totally free, but here you will see one double bond. Along with that you will see another benzene ring here. This is the substituent. Along with that you will see another R group here. Okay, so this is the main benzodiazepine structure, BDZ structure. Now numbering will be start from which side? So numbering will start from nitrogen according to OSNP. You know about OSNP. So in this oxygen, then sulfur, then nitrogen, these are the priority order. So these are most preferred: oxygen, then sulfur, then nitrogen, then phosphorus. So numbering will start from nitrogen. So nitrogen will be first position. Then this one will be second position, third position, fourth position, fifth position, then sixth position, seventh, eighth, and ninth position. These two are at branch bridge. So these two are bridge carbon, and bridge carbon are not numbered in this sequence. Now see, this benzodiazepine has three fragments. Three fragments mean this one is the fragment 1, this one is the fragment 2, and this one is the fragment 3. Okay, so fragment 1 is mainly benzene ring. Yes or no? So this is called ring A. Fragment 2 is called ring B. Fragment 2, or you can say ring B. This is the third fragment, that is fragment 3. Or you can say ring C. Okay, so now in structural activity relationship there will be three modification. Why three modification? There are three fragments: fragment 1, fragment 2, and fragment 3. So modification will be also in 3. That is, first modification will be in ring A, then modification will be in ring B, then modification will be in ring C. Now we will see that. So in ring A, that is, in that ring A, one R group is there. In that R group, now should I write properly or write just in the boxes? Wait a second please. So you have to remember that this ring A contains one R group at 7th position. So this is very important point, very important, that the electronegative atom should be present at 7th position. Highly electronegative atom should be present at 7th position. So what will happen if highly electronegative group is present at 7th position? It will increase the pharmacological activity, pH activity. Okay, next, this is the point 1 in the point, that modification of ring A. So point A is modification of ring A. In that you will write point 1, that in 7th position more electronegative group should be there. So more electronegative group will increase the pharmacological activity. Next, write point 2, that if the substituents are present at C6, C8 and C9, C6, C8 and C9, if substituents are present, then it will lead to decrease in pharmacological activity. So it will lead to decrease pharmacological activity. Okay, this is the second point. Next we will move towards ring B. So then modification in ring B. What will be the modification in ring B? In ring B, that R group, that is at first position. In nitrogen we will see a substituent R. So in that R group, if alkyl group is present, if alkyl group is present, then what will happen? This alkyl group substituted at first position increase the activity of the benzodiazepines. So in that case, if any kind of alkyl group, that is CH3 or C2H5 or something like this present, then what will happen? It will increase the activity of benzodiazepine. It will increase the pharmacological activity. of benzodiazepines, BDZ. Okay. Next, third position, one R group is there. If that R group is containing OH, that is hydroxy group, then this hydroxy group will ultimately lead to the short acting activity of the benzodiazepines. So I will decrease duration or activity time. So it presence of hydroxyl group at third position leads to short acting benzodiazepine. So you can say short acting benzodiazepines are having hydroxy group at third position. Okay. Next, at the aromatic benzene ring, this one, the aromatic benzene ring is present at fifth position. So what is the position here? This is the fifth position. In this fifth position, one aromatic benzene ring should be present. So the presence of aromatic benzene ring at fifth position increase the activity of benzodiazepines. You can pause and write the points. These are the main important points. Okay. I forgot to tell you one important point, that is these highly electronegative groups. So what are they? They are electron withdrawing group. The example of the highly electronegative group are maybe chlorine group, or you can say nitro group. So NO2, Cl, like this. These are electron withdrawing groups. Okay. Next, in the ring C. In ring C, if you focus on ring C, you will see one R group present here. So in this R group, this is at ortho position with this ring, yes or no? So ortho position, meta position, para position. With fifth position, this is at ortho position. So in ortho position, if this ortho position is substituted with electronegative atoms like chlorine, bromine, fluorine, nitrogen, like this. So if this ortho position is substituted with electronegative atoms, electronegative, then it will ultimately increase the activity. It will ultimately increase the activity of benzodiazepines. Okay, thank you.